hits aren't hard enough.
Guys hits aren't hard enough?
Yep.
He's teasing Rachel.
Yeah.
I think.
Like he just likes the spandex. It's just sad.
Okay, I'm videotaping. All right. So this part of of our dynamics unit is very similar to a part in kinematics, where we needed to make a new diagram based on x and y coordinates and kind of make an overall net velocity. For this one, though, since we're dealing with dynamics, what we need to do is we need to look at the situations we have, make our total x and our total y, and then find Fnet, an Fnet vector. Because when we think about Fnet, as you guys have been practicing, Fnet is what you need to use if you're going to find anything about acceleration or mass, right? Or velocity, because that applies to acceleration. So finding Fnet is super important.
You're late.
Oh, come on, shh, come on.
Thanks.
All right, so from kinematics, we know that vectors can also be in 2 dimensions. So having vertical and horizontal. So things that are at an angle, right? So things that are at an angle. So anything at an angle is going to have an x component and a y component. So as I was saying, the same is true for a force vector. So for example, say an object can have a force pushing on it with 70 newtons east. At the same time, a force could also be pushing on it at 30 newtons south. So there could be like 2 things acting on one object. So say you try and push this this way, and I'll try and push it that way. Okay, 2 forces are acting. You keep pushing. Her force is stronger, so it's going to push this way. Okay, but 2 forces can act on one object. See that? The Fnet would have been the overall vector that made it go this way. Okay, so it would have taken Lisa's and minus mine, because mine was less. So if we were to draw this, say, and just like kinematics, we draw tip to tail. So the tip of the one arrow should be on the tail of the other arrow. So say we have 70 newtons east and 30 newtons south. So then those are 2 forces. So this would be like, this is our F of, that's like Fy, and this is Fx. But you want to get the overall picture to be able to work with the equations and stuff. So you'd go from the start and go to the bottom and draw your arrow. And this black line would be like your Fnet. So you can find the magnitude of that vector, but we know force is magnitude and direction. So then you would also have to find the angle there using trig. So very similar to our kinematics unit, except now we're talking about force. So generally, to solve the question by looking at the problem as a whole, we need to use Fnet. Fnet is very important if we're asking questions about the whole system or about the acceleration within the system, etc. So in order to find Fnet, it's the overall vector of the question. So when we're solving for 2D problems, if vectors are perpendicular to each other, meaning like if they're like this and like this, if it's just one up and one over, like just something north and south and something east and west, that's a little bit more simple because then you can just draw your overall vector and solve for it. That's like here. if the vectors are not perpendicular, that means that there would be like, say there's one going at an angle, and then there's, say, one going north and south. You need to be able to break those down. So you need to be able to break it down into its x and its y, and here would be its y, etc. So this takes a couple more steps if there's things going at angles. So just an example. So say we have like vector number 1. Say it's going to the right or east. When we think about this vector, we can break it up into its x and its y components. So we would say x1 is equal to whatever number that vector is given to us. And y1 is 0, because this is not up or down. It's just going, it's a horizontal vector. So similarly, if we were to do vector 2, say it's a vertical vector, our x2 would be 0 because there's no horizontal to this, and y2 would be whatever number we're given. And I should say these are all in newtons because we're dealing with force here. But say, as I was mentioning, you were given a vector that's at an angle. You need to break it down to tell me it's x and it's y. So say this would be x3 and here's y3. So how do you find those? What method can I use? Mathematical method. Starts with a T. Trig. Yeah. So say your problem had all of these vectors. Oh, I forgot to put vector 3 here, sorry. You add up the total of all of those vectors. So to find, say, x total, so xt, you go x1 plus x2 plus x3. And y total is y1 plus y2 plus y3. Because if you think about it logically, there's 3 different things happening all at the same time. So you break them down into their components, their horizontal, vertical. Then you add all of the horizontal components together and all of the vertical components. Then you draw a new triangle to see overall what happened for this diagram. So you draw in, say here is x total, so I'll just put xt. And we have our yt. From start to finish, this would be our f dent. So you find the magnitude of this by using your a squared plus b squared equals c squared. And you find the direction using your trigonometry. So in this case, it's tan theta, or theta equals tan inverse, sorry. Times by opposite over adjacent. So anytime a question asks you to find the direction, that means find the angle, okay? Sometimes I think on your last kinematics unit exam, there was 1 or 2 of you that just wrote in northwest or something, but you didn't give me the angle. So assume that whenever it says find the direction, that means find the angle, like specific angle, okay? Any questions about this? Is this somewhat good in your head because you've done it a bit in kinematics? I'm not. Okay, we're together. All right. You're not brain dead even though it's Friday? Good. Good. These are kind of fun. I think they're kind of fun. Let's try one. So one person is pushing on an object with a force of 800 newtons to the west, while another person pushes on the object with a force of 550 newtons to the south. What is the acceleration of the object if it has a mass of 62 kilograms? So when you think about this, if we are looking, we have mass and we're looking for acceleration, you should be kind of thinking, okay, I'm looking to use this formula. F net is equal to m times a. Because we have our mass, we're looking for our acceleration, and our F net is what we can find from the given forces. So I'm going to break these down into x and y components. So here, my 800 newtons to the west, so 800 newtons, while another person is pushing with 550 newtons to the south. So I'm going to draw these arrows together now because I know neither of them are at an angle, so I can just make my triangle right away. Okay, so this is 550 newtons. So overall, this black line here, this is my F net. Now always start kind of, the angle that you're trying to find is where you started from. So that would be the angle that you're looking for. So first you find the magnitude of your F net. You can use a squared plus b squared is equal to c squared. So rearrange to solve for c is the square root of 550 squared plus 800 squared. $970? 970.824, and this is all in newtons. So this is my F net. This is only the magnitude so far of my F net though. And I do need to get my, my angle in order to find the angle of my acceleration, because acceleration is magnitude and direction. So I'm going to find my angle now. So angle is equal to tan inverse times by opposite over adjacent, which is 550 over 800. What's my angle, Lisa?
35 south-southwest.
35? Rounded?
Yeah.
That's 35? Yeah. So I'll put in 34.508, right? And so then rounded. Are we two sig digs? Yeah, you're right. 35 degrees south of west, as you said. Okay, so my overall F net then, I'm going to add that here, comma, 35 degrees south of west. Yeah. For this one?
Is your calculator degree?
Yeah, degree mode. Maybe you're still in radian if you reset your calculator. Good suggestion. Okay, but we are looking for acceleration was what we were trying to find. So my M, I was told in my question, is 62 kilograms. My F net, I'll just use the magnitude for right now to do my calculation. 970.824 newtons. And I'm looking for my A. So A is equal to F net divided by M. A is equal to 970.824, etc. newtons divided by 62 kilograms. So A is 15.915 meters per second squared. So now I can put that into sig digs and add my direction, because I need direction for my acceleration. So my final answer is 16 meters per second squared, comma, 35 degrees south of west. Are we good on that? Did that one work, Rael, if you changed your settings? Yeah? Okay, good.